Welcome! In this section, we will explore the fouling phenomena in water treatment technologies. We will start with a brief introduction to membrane types and the driving forces in membrane separation processes. Richard W. Baker defined the membrane as a discrete, thin interface that moderates the permeation of chemical species in contact with it. I would like to show you 4 different types of membranes used for water purification, according to the driving force they choose for the separation process. The first driving force is hydraulic pressure, used for separating water from contaminants. The second driving force is temperature, used for separating water in its gas phase from contaminants. The third one is chemical potential, in the form of either partial pressure or concentration of the solutes. And the fourth one is electric potential, mainly for separating charged species such as ions. For each of these processes, different membranes are used, as well as the components that pass through the membranes. For pressure-driven membranes, primarily polymeric membranes utilizing microfiltration, ultrafiltration, nanofiltration, and reverse osmosis technique, the purified product material that passes through the membrane is water in the liquid phase. For temperature-driven membrane, a process termed membrane distillation is applied, where the contaminated components are ejected and the desalinated water passes through the membrane in a gas phase. For chemical potential-driven membranes, several processes are mentioned here. The first is called pervaporation, where the contaminated components are in the permeate and pass through the membrane, while the clean water in the liquid phase is rejected by the membrane. This process can be applied to separate high vapor pressure contaminants, where the driving force for separation is the partial pressure of the components on the two sides of the membrane. In this method, we are interested in the clean retentate. The second process is dialysis, where the membrane separates components from the water in the liquid phase. Solute pass through the membrane in the liquid phase to the permeate. In this process, we are interested in the purified retentate. In the third process, forward osmosis, clean water passes through the membrane toward concentrated solution, allowing the contaminated components to be rejected by the membrane in the retentate. In this process, we are interested in the purified permeate. For electric potential-driven membranes, one major process is electrodialysis, where the cations and anions pass through the ion exchange membrane driven by electric potential. The purified water is the diluate, while the cations and anions are concentrated in the concentrate flow. It should be mentioned that in each of the mentioned membrane processes, fouling may occur. In the next video, we will define fouling and learn about different fouling types and their characteristics.